And again, the solutions to these are in Schoology. So for number 1, we have 2 semicircles and 2 line segments. From -5 to 5, and this is the graph of f prime. So notice they didn't make you do fundamental theorem of calculus to figure out it was f prime. Sometimes they'll say, like, f is the integral from 0 to x of g of x or whatever, right? They didn't do that. They just said, hey, this is f prime. So anyway, so this is f prime. We want to know where f has a relative max. F has a relative max wherever f prime changes from positive to negative. Where does f prime change from positive to negative? -3 and 4. So your answer would be f has a relative max at x equals -3 and 4 because f prime changes from positive to negative at -3 and 4. So you do have to know your because statements. All right, we want to know where f has a point of inflection. F has a point of inflection when f double prime changes sign. Oh, yes.
When it's even though it doesn't say explain, are you just expected to know the explain?
Probably when this was made, you probably didn't have to. They started doing this was in like 2006 or 2007. They started making you write because statements sometime not that long after that, though. So, yeah, now I'm sure it would say justify your answer. Okay, so find all values, point of inflection, where f double prime changes sign, where f changes concavity. So how do we know when f double prime changes sign? Well, f double prime is the slope of f prime. So f double prime is positive when f prime is increasing and negative when f prime is decreasing. So whenever f prime changes from increasing to decreasing or decreasing to increasing, that means f double prime is changing sign, and therefore f has a point of inflection. So you got to get your head kind of wrapped around all that. So anyway, so where does f have a point of inflection? What's the first x value? -4, then -1 and 2. And your answer could be because f double prime changes sign or because f changes from, don't just say direction, f changes from increasing to decreasing or decreasing to increasing. All right. Part C, find all intervals where f is concave up and also has a positive slope. So, yeah, okay, well worded. F is concave up when f double prime is positive, which means f prime is increasing. F has a positive slope when f prime is positive, right? Okay, so we're looking for where f prime is both positive and increasing. Positive means above the x-axis. Increasing means going up. So tell me the first interval where f prime is both positive and increasing. -5 to -4. What's the second interval? 1 to 2. 1 to 2. So -5 to -4 and 1 to 2 because f prime is both above the x-axis, which means f prime is positive, which means f is increasing, and f prime is increasing, which means f double prime is positive, which means f is concave up. All right. Find the absolute min of f over the closed interval from -5 to 5. So when you find absolute maxes and mins, you have to test your critical numbers and your endpoints, right? So our critical numbers are where f prime is 0 or undefined. That would be -3, 1, and 4. So right now we are facing a test at x equals -5, -3, 1, 4, and 5. Now, they only asked us for the minimum. So, Cassian, yeah. Is what undefined? F prime? I see a point right there. It's even labeled 2, 2. How could it be undefined if there's a point? What's undefined? At x equals 2. What's undefined? F double prime, right? It's derivative. The derivative of f prime is undefined. However, f is defined, or f prime is defined, which means f also has to be defined, right? Okay, good question. All right, so because they only ask for an absolute min, you can justify, if you want to write it out in words, you can kill off a couple of these answer choices. So we can kill off -3 and 4 and not even have to test them. Why can I remove -3 and 4 without having to test them? Because those are relative maxes. You're not going to have an absolute min at a relative max, right? Can't happen. So you don't have to test those. So you could, if you're worried that they're going to wonder why didn't you test all your critical numbers, you could say -3 and 4 are relative maxes and therefore don't have to be tested, right? All right. So we need to find f of -5, f of 1, and f of 5. Well, the good news is f of 1 is given, right? So you don't have to find f of 1. I'm going to go kind of in reverse order. I'm going to find f of 5 first. So we know f of 1. We want f of 5. I'm going to close this door. It's just too loud. All right, all these students are wandering around the halls right now. Okay. Okay. So, the end point the ending value equals the starting value plus the net change, right? I'm going to write it out differently. I'm going to just do a little FTC part 2 here, and I'm just going to do definite integral. The integral from 1 to 5, that's what we want, right? Of f prime equals f of 5 minus f of 1. So if you forget the whole net change thing, you can always just write a definite integral, and that'll help you figure it out, right? Okay, so that means f of 5 equals f of 1 plus this definite integral. So f of 5 equals, I'll write it all out, f of 1 plus the definite integral. So f of 1 is given, it's 3. We want the definite integral from 1 to 5 of f prime. Ooh, it's a good thing we have the graph of f prime, right? So from 1 to 4, we have a triangle, 1, 2, 3, so 1/2 times 3 times 2. So the area of this triangle is 3. The area of this little triangle is 1/2. However, this little triangle is below the x-axis, so we have to go 3 plus 3 minus 1/2. So 6 minus 1/2, or 5 1/2, or 11 halves, or however you want to do it, right? Okay. All right, so there's your f of 5. Now we got to find f of -5. So you can't go from 1 to -5. You got to go -5 to 1. You can go 1 to -5. It's just going to all be backwards. So I would start by doing an integral from -5 to 1, because again, this is what we want, this is what we know, of f prime equals, that's f of 1 minus f of -5. So now f of -5 equals f of 1 minus the integral from -5 to 1. Why is it minus? It's because you're going kind of backwards. Because we know f of 1 and we're kind of going backwards, that's where that negative kind of gets thrown in. Just follow the math. The math won't lead you wrong. So anyway, so f of 1 is 3. We know that. Now we got to subtract this guy, the integral from -5 to 1. So this is a circle, radius of 1, area is pi, except it's half of that, so pi halves. This radius of 2, area is 4 pi, but it's half of that, so it's 2 pi. So we end up with 3 minus whatever this integral is, which is pi halves minus 2 pi. So this ends up giving us 3 minus pi halves plus 2 pi. Well, 2 pi is around 6. This is plus 3, so 9 minus 1.5, roughly 7.5-ish, right? So this is like around 7.5-ish. This is around 5.5. So that's our absolute min. It's 3. Because that's our lowest value. Fun with maxes and mins. Keegan, yes.
On the AP test, would these kind of problems be expected to be a little harder? Because from this one, it seemed kind of easy because if you kind of eyeballed it, you could kind of assume that it was probably just going to be 1 to 3 because the amount under was so much greater than the amount all the way over 5.
Oh, you mean the point, like f of 1 equals 3? Yeah, because if you start here, to go here, you're like adding way more than you're subtracting, so the 5 would be bigger. And if you start here, you're subtracting way more than you're adding, but you do opposite because you're going backwards. So yeah, you could just think about it. However, I guarantee you that on yours, it would say JYA. Yeah, and then you have to do the work. All right. Okay. Any other questions before I erase all this? Just so you know, you could not have done this on your calculator. This is a no calculator problem, right? Okay. No, it's recording. Oh, the thing isn't showing. That little thing doesn't show up from time to time, but it really is recording. It has trouble when I work in Word showing the little recordy thing. But like if I go here, wait. There it is. Like you can't, it's hard to see, but it's there. It's recording. I don't want to pull up the Calc 3 final while I am recording. Wait, where did my document go? There it is. All right. Just so you know, all these solutions, they're not beautiful, but they are in Schoology. So, all right. Okay, number 2. You know what? I'm going to pull up the solutions for this one because we just did this unit. My guess is you guys all could do this without too much trouble. And this way I don't have to sit there and sketch the slope field. So, let's see. Exam, free response, answer key. Okay. Oh, you know what? Did you look at this? For 2007, they required all this justification even though they didn't ask for it. So look at that. So you had to write all your because statements even though they didn't ask you for it. Justification, explanation. Yeah. So tough luck for you. Okay. So now we're going to 2006. Check your slope field. Tell me if you have any issues or questions. Seems good. Tangent line. What 2 things do we need for a tangent line? Point and a slope. The point, is the point given? Yes? Okay. Point is given. Where do you get slope from? The differential equation. So you plug it in, you get a slope of 2, and then your equation it's bigger. Whoa. Ooh, I don't want it. That's weird. Okay. All right. So that whole part was just 1 point. Part C, 6 points. That is money if you did it right. Okay. All right. So 6 points. You got a point if you separated the variables, a point for each antiderivative, and a point for writing plus C. So these first 2 lines, 4 out of the 6 points. All right. Are there any questions on either of the antiderivatives? Y'all comfortable with that? Luke, how you doing? You're good? Okay. All right. So now you got to solve for C. If you solve for C when it looks like this, you get -1/4. All right. So if I put my -1/4 in, I have negative 1 over y equals negative x squared over 4 minus 1 over 4. So the first thing I would do is like goodbye negatives, right? Just kill them all. Okay. All right. When you have to flip a y, you can either do it by thinking cross multiplication or by flipping both sides. They're both fine, but if you do the flip both sides thing, you can't just flip in each individual fraction. Algebra doesn't work like that. It's the whole side. So the whole side gets put under a 1. So it's 1 over the whole side. All right, so when you solve for y, this is fine if you have 1 over the whole side, or if you multiply top and bottom by 4 and clean up and get rid of your complex fraction, that would be lovely. Right? Oh, the hands are up. Faith.
If so, on our test, would you accept the unsimplified answer?
Oh yeah, this one?
Yeah.
Oh, unless it says no complex fractions, which it might. I honestly don't know. If there's a complex fraction in an answer, which I also don't know, honestly. Like, I'm not lying to you. So.
On the AB question, our test, can we leave it unsimplified?
Oh yeah, they don't care.
Complex fraction.
Yep, they don't care. Yes.
On Schoology, do you have like the old chapters archived with like all the big quiz answers?
Yeah, they're all there. Yeah, I haven't turned anything off.
Is it like a different course?
It's under your archived courses.
Oh, okay.
Yeah, you have to go to your archived courses.
Course for the semester.
No, it's each term is its own course. Yes.
On the AP test, can you do negative exponents?
Yeah, they don't care. Anything that's equivalent to correct is correct. Yeah. It does have to be solved for y though. Right? If it says solve for y, you gotta solve it for the y has to be by itself. But if you have y equals this whole big thing, negative 1, that's fine. Yep. All right. Good. Any other questions on slope fields and differential equations? Pretty straightforward. All right. What's your third problem? Oh, PVA. Okay. Oh, PVA is on the whiteboards. Don't look at the whiteboards. So how about when I say go up to your whiteboard, erase what's there, and then solve the PVA problem. I'm going to give you about 5 minutes or so. Go.